Gary Burton, the Water Watcher guy here. Today we're going to talk about where the water that we use comes from. Most of us probably don't put much thought into it, but there's really only two places: surface water and groundwater. Let's take a closer look at what those two different types of water are and where they come from. So surface water can be anything that we can see on the surface. From a small mountain stream like this, from a small mountain stream to the largest rivers, another example of surface water. Here we have the Missouri River. Here we have another example of surface water. We're looking at Lakeside up towards Devil's Elbow here. Here we have Canyon Ferry Lake, one of the larger lakes in Montana, another example of surface water. Well, here we are below Canyon Ferry Dam on the Missouri River, and an interesting thing I would like to point out here is this big silver pipe. This is where water is collected and sent to the Helena regulating reservoir, and from there on to the Missouri River drinking water plant. So this is one of two sources of City of Helena drinking water, straight from the Missouri River, where it is then cleaned and sent to town for everyone to use. Now, Helena primarily uses 10 Mile Creek, which we'll take a look at in a little bit. Here we're looking at the Missouri River water treatment plant for the City of Helena. This is one of two sites where water is cleaned before it is sent to the city for the people to use. This is kind of the secondary plant. The main reason is that we have to pump this water uphill to the City of Helena. It costs a lot of money to pump that. So the primary plant is the 10 Mile water treatment plant. We saw earlier the silver pipe where the water leaves the Missouri River and brings it to this facility. Well, here we are at 10 Mile Creek, another example of surface water. But 10 Mile Creek is unique in that it is the primary source of drinking water for the City of Helena. Now again, it needs to be cleaned before it is sent to town, but this is where they get the water to clean and send to town for everyone to use. So here we are at the 10 Mile water treatment plant for the City of Helena. You can see the tan building back there in the distance. That is where the water from 10 Mile Creek goes to be cleaned before it is sent to town. It's a fairly complicated process, and we'll get into that at a later date. Here we are at the City of Helena wastewater treatment plant. This is where all of the water for the City of Helena gets sent to be cleaned. Now remember, there's a set amount of water on Earth. It's either clean or it's dirty. So as long as we clean and recycle the water that we use, we will always have clean water available. We drink the same water that the dinosaurs drank millions of years ago. Well, here we are looking at Helena Sand and gravel pit. Nothing too interesting until we take note of the water. Well, since we can see it on the surface, it must be surface water. But it's a little bit different. I don't know how many of you have ever dug a hole on the beach out next to the lake, but you don't have to dig very deep before water starts seeping up from the ground into your hole. This is exactly what has happened here. They dug the hole to get the gravel, water started seeping in from the ground. Now, water underground sometimes is very deep, sometimes just a couple feet under the surface. That fluctuates depending on the time of year, just like the level of water in the creeks and lakes and rivers. As you can see, we still have snow in the mountains off in the distance. As that snow melts, our rivers will fill up. A lot of that water soaks into the ground and becomes part of the groundwater. That is called recharge. Water that soaks in from rivers, lakes, snow, and rain. So what we're looking at once upon a time was groundwater, and we dug deep enough into the ground that it is now surface water. So we've already looked at some examples of surface water, and I did mention and show you one example of groundwater that became surface water at the Helena Sand and Gravel Pit. And now we're going to talk about people in the valley that do not use city water. So they are using groundwater, which comes from a well. Now, we have the 10-mile plant that cleans the city water. We have the wastewater plant that cleans the used city water. But if you are out of the city limits, then you're using something completely different. Let's take a closer look. Here we're looking at a typical household well. Now, it's not a well like you probably have seen in books or movies where they lower the bucket down to get the water. Nowadays we use electricity. Inside that metal pipe underground is an electric pump, and there's one pipe leading into the house taking clean water in, pumped by electricity. Next to it we just have a spigot. Some of you guys probably have these in your yards. If you're out of the city limits, you are using groundwater. Water from the aquifer. Now, it's not a big lake underwater, because the ground would cave in if it was like that, but the little tiny air pockets between the grains of sand and gravel and rock, that's what holds the water. It's very similar to a sponge. You can see if the sponge is wet, but you cannot see the water that's in it. So not very exciting there, just a metal pipe. Down inside of it, a pump. The pump pumps water to the house. Now, every bit of water that is used in a house, sinks, showers, dishwashers, bathtubs, and toilets, of course, that is all now wastewater, and it leaves the house in one pipe. Here we are looking at access to that pipe. Now, these pipes that lead to the house and from the house, they're buried underground to make sure that they do not freeze in the winter time. Now we'll take a little walk and follow where this pipe would go underground, under the patio, under the grass. Now remember, this is wastewater leaving the house. And now we have our two concrete lids that are part of the septic tank. Let's take a closer look inside of a septic tank. Very heavy lids. So here we have the lid off of the septic tank, and we'll get a closer look down here, and you can see that it is filthy gross down in here. Try and get my shadow out of the way. Lots and lots of waste. Human waste, food waste, hopefully not any trash, because as long as it's biodegradable, the bacteria in the tank will break that down and gobble it up. The same bacteria are used in the tanks at the City of Helena wastewater plant, only their tanks are a lot bigger. You can see we have a pipe leaving the septic tank. So the sludge and waste stays in the tank, and the water leaves the tank through that pipe. Out underground we have what is called a treatment field or drain field, where the water drains out of the pipe and filters down through the soil, where Mother Nature cleans whatever remaining waste is in the water, and that water eventually makes its way back to the aquifer. Here we're looking at a septic truck that has emptied some septic tanks, and they are required by law to bring it to the City of Helena wastewater treatment plant to dispose of. This prevents illegal disposal of dumping it out in the nearest creek or out in a field somewhere. Alright, water watchers, now that we have seen some examples of surface water and seen a well and a septic tank, we're going to take a look at my model here. This is a model of an aquifer. It is not an ant farm, no ants in it. But you can see we have different layers of sand and gravel and rock down on the bottom, and this is what it might look like underground if we could see there. Now, the aquifer is what holds the water. So here we have just plain old water. I'm going to add some to the top, and you can slowly see it sinking down in, and the soil there is starting to change color. So this is recharge. I mentioned that earlier. Rain and snow falls on the surface, and you can see it starts to soak into the ground. But once it's saturated, you wouldn't see it change color anymore. Then it's very hard to see. So here we'll fill up a lake, and some of that water will soak into the ground as well. For any of you that have dug a hole on the beach next to the lake, you know that your hole starts filling up with water. We talked about that earlier. So we'll add more here, and I'll just simply put my bottle there to drain into the side. Have another one here. So again, recharge. Rain and snow falls on the surface. Any of that water that soaks into the ground is now part of the aquifer. And a well, like we saw outside, is simply like a straw that goes underground, and then the pump pumps the water to the house. One pipe going into the house, taking clean water in, and then one pipe taking water out of the house. Wastewater goes to the septic tank. Now, in certain places, you'll have community systems of wells and septics. They pretty much work the same way as an individual well and septic would work, like what I have here at my house in the valley. So I'm out of the city limits. I use groundwater from a well, and I use a septic tank to clean my wastewater. Okay, so we pretty much have our aquifer here recharging with water. And now we're going to see if we can get some water out of the aquifer. So here, this flask here is going to, we're going to pretend that this is my house, just for our demonstration today. So I'll hook my hand pump up to my house, and then I will hook my pipe up to my well, and I'll use this deep one right here that we can see goes all the way down to the bottom, and we'll start pumping on there, and we'll see if we can get some water. So watch inside of the flask, and you'll see that we already have water. So for a real house, it would be an electric pump, not a hand pump. You turn on the faucet, the pump turns on, pumps water to the house and out of the faucet. Lots and lots of water. Now, if you remember, I showed you earlier how the pipe leading from the house is underground going to the septic tank. Okay? Well, when I built my house a few years back, that pipe got broken when they came and put the phone line in. So if that pipe is broken, the water cannot get to the septic tank. So some of that blue water from the toilet you guys have seen before, I saved some. So here I'm going to show you how some of that water might leak from my broken pipe down underground. And let me move my flask here. If you take a look right down here, we can see a big blue plume of pollution underground. Now, if it's underground, we can't see it. So we continue using water at my house, doing dishes, cooking dinner, taking a shower, using the restroom, brushing our teeth. So as we continue to use water, that pump is sucking water from the aquifer. And now if you take a look at my flask, you can see that my well has sucked that pollution into my drinking water. What we're looking at here is an example of what is called non-point pollution. Non-point means it's pollution that did not go directly to a specific spot in the water and pollute it. It went underground and slowly dispersed into the soil and the aquifer. Okay? So now I have a major problem with my well. It's starting to taste pretty funny. It smells bad. So I would have to get a well test done to make sure that my water is safe to drink. Anytime you drill a well in Montana, that's the law. It has to be tested to make sure it's safe. Typically, water right out of the ground here in Helena is perfectly fine and safe for people to use. Well, as you can see from my flask here, my water is polluted with my blue food coloring. You didn't really think it was toilet water, did you? So now the problem is, how are we going to clean that? Well, this brings up a very important point when we're dealing with water pollution. A lot of times when water becomes polluted, it's either impossible to clean it or it's too expensive to clean it. That is why we want to prevent things like this from happening so that we don't have to pay later to clean them. Now, only part of this story is true. They did cut the pipe leading to my septic when they put the phone line in, but it didn't leak and leak and leak underground because every time we flushed the toilet, the water couldn't leave. So it backed up into the house. We figured out very quickly that there was a problem with the pipe, dug it up, fixed it. Now, over time, a septic tank could fail. That is why you have the septic trucks, which we saw earlier, that come and pump the septic tank. Over time, they're going to fill up with sludge and waste if the bacteria can't gobble it all up. They recommend about every 4 or 5 years you have your septic tank pumped, whether it needs it or not. It's kind of like brushing your teeth. It's routine maintenance to prevent further problems. Those trucks have to take that waste to the City of Helena wastewater plant. If they don't, they're breaking the law. Years and years and years ago, those septic trucks maybe went out to Prickly Pear and dumped it straight into the creek. That is a different type of pollution called point pollution. Point pollution is an exact spot on a map where water is becoming polluted. So the example of the septic truck dumping into Prickly Pear, point pollution. The example of a septic tank leaking underground would be non-point pollution. Those are two words that were on your crossword that were not in the comic book. So we've been talking about surface water and groundwater. Those are the two places that we get our water from. Just depends where you live, which type of water you use. If you're in the city, your used water gets recycled by the Helena wastewater treatment plant. If you're out of the city limits, then you're using the aquifer and a septic tank. The septic tank with a drain field or treatment field where the water drains out of the tank and slowly filters down through the layers of sand and gravel and rock. Now, I still have a problem with my well, so I'm going to use something to clean it that is similar, well, exactly the same thing that they use at the Helena water treatment plant, and that is chlorine. Now, in this jug I have chlorine. You can smell it. It smells just like we're at the swimming pool. If we had smell-o-vision, you could smell it too, but then when I put the camera in the septic tank, you would have smelled that as well. So probably better we don't. So I'll take my mixture of chlorine and water, and I'm just using simple chlorine bleach from the laundry room. I'm going to squirt this down into my well. And this is what you would do in real life if you were going to clean a well. It's called chlorinating a well. Simple chlorine bleach dumped down the well. That would be dumped down that pipe you saw in the video. And that mixes with the water. Then you go in the house and you turn on all the faucets, turn on the showers, turn on the sinks, and you let that water run. Now, chlorine's very, very dangerous. But when you mix 1 jug of chlorine with thousands and thousands and maybe even millions of gallons of water down in the aquifer, and then you pump and pump and pump and pump, and pretty soon in the house you'll smell the chlorine cycling through the pipes and the faucets. It'll smell like you're at the swimming pool. I can smell it right now. Now if you look down underground, you can see that our blue food coloring is slowly disappearing. Now, inside the flask we still have a lot of that, but that is now wastewater. And actually, as the chlorine settles into that flask as well, I may even dump some in there to speed up the process, that chlorine would kill any of the germs that are down inside of the well. And after the smell in the house goes away, you can turn the faucets off, let that chlorine sit for a while, and the nice thing about chlorine is it does evaporate. A lot of people don't like the taste of the city of Helena water. Oh, I personally can't taste it, but if you're one of those people that is a super taster, you can fill up a pitcher of water, put it in the fridge overnight, and by morning that chlorine is gone. It evaporates away. So let me put a little chlorine in my flask here, and you'll be able to see how you can speed up the process of cleaning that well. So pour a little in there. I don't know if that was going to be enough to do away with all that food coloring, but we'll swish it around. And as that sits, it'll probably start to get clearer. Doesn't look like I probably added enough to get rid of all of that pollution or not, but you see how it works. And that's what you would do in real life to clean a well. So hopefully now, with looking at the model here, you understand more about what an aquifer actually is and how it works and how a well can get water from that aquifer. If you're in the city of Helena, you're not using an aquifer, you're using water right out of 10 Mile Creek or the Missouri River. But remember, it is cleaned first. If you're using groundwater, Mother Nature cleans it for us.